Hi class, today you're going to learn about what scientific notation is. So scientific notation is a short way to write very large or very small numbers. So when you have those giant numbers that have lots of zeros, lots of decimal places, things like that, it's a different way to write those without having to write out all those numbers. So when you write a number in scientific notation, it'll be written in this format, where this A, that's a number between 1 and 10. Now it can be equal to 1, but it can't be equal to 10. So it's going to be a single digit number with perhaps a decimal after it. Okay, and then it'll always say times 10 to some power, and it does say that n is going to be an integer, so that's going to be a whole number that your exponent will be. All right, so for example, if you look at all of these right here, these are all written in scientific notation. So this is what it looks like. So notice the first number is a number between 1 and 10, and they all say times 10 to some exponent. Okay, so whenever I want to write it in standard form, that's talking about the normal way that we write numbers. So it's showing what is this telling me, or what number is this talking about. All right, so this is pretty easy to do. Whenever you see the exponent, it's saying times 10 to the 5th power. Well, if you remember, multiplying by 10 just moves your decimal place over. So if you multiply times 10 to the 5th power, you're essentially moving your decimal over 5 times, because every time you multiply by 10, it moves it over. So if I start off writing that 1.35, and then I'm going to move my decimal over 5 times. So 1, 2, 3, 4, 5. So I'm essentially moving it from here to here, 5 spots over. And then anytime you have blanks, you just fill those in with zeros. Okay, now we don't want to leave our answer looking like that. We want to rewrite it so that it looks like an actual number. So we rewrite it. We've got 1, 3, 5, and then there are 3 zeros there. Okay, and then don't forget, you have commas. When you have large numbers, there's commas every 3 numbers. So if I move 3 numbers back, I would put a comma there, and then that's it. So this is equivalent to 135,000. Okay, now you might not think this is generally the short way to write really large numbers. Well, this number, although large, it's not that large, so it's not necessarily really a shorter way for this. It's just a different way to write it. Okay. So this one, now it's 2.7 times 10 to the negative 3. So you'll notice the negative exponent. The negative exponent is similar. We do the same kind of thing as with our positive exponent, but when it's negative, we're making it smaller. Instead of moving our decimal to the right, we're going to move it backwards and make it smaller. So if I have that 2.7 that I start with, and I have 10 to the negative 3, I'm going to move it 3 spots backwards. Okay, so I'm going to move it 1, 2, 3 spots back to right there. Okay, and then again, those blank spots, we fill those in with zeros. So when I rewrite this, that would be 0.0027. All right, so that's the standard form version of the number, and that's the scientific notation format. All right, so positive exponents, we move forward, move it to the right to make it bigger. Negative exponents, we move them to the left and make it smaller. All right, so now we have 2.87 times 10 to the 9th. Now we actually have a pretty big exponent here. So I'll start off with my 2.87, and I'm going to move my decimal 9 places, because I'm multiplying by 9 tens, to the right since it's positive. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, so that's a lot of spaces this time. So I've got the 2 places for the numbers, which means I should have 7 zeros here. 1, 2, 3, 4, 5, 6, 7. All right, so let's rewrite this correctly then. So 2, 8, 7, and then 7 zeros. 2, 3, 4, 5, 6, 7. So you should have a comma here, here, and here. All right, so one common misconception that people have is they think that the exponent represents how many zeros you should have, when that in fact is not true. Occasionally it'll be true, but most of the time it's not. What the exponent means is how many times you move your decimal over. So since it's 9, well, we have to move it 2 places to clear the decimal part, which means I have 7 more zeros in addition. So I've got the 2 decimal places plus the 7 zeros makes the 9 spots that I move it over. All right, so one more, 1.9 times 10 to the negative 5th. So this time it's a negative exponent. So that means it's a small number. So negative exponents are small numbers, positive exponents are big numbers. So I'm going to move my decimal to the left. So 1, 2, 3, 4, 5. Move my decimal there. So I've got 1, 2, 3, 4 zeros to fill it in. Okay, so again, let's rewrite that 0.0000019. Okay. By the way, just something I've noticed before, make sure you don't put commas in decimals. You only put commas in those large numbers. Okay. All right. So that's how to change from scientific notation to standard form.